Hello everyone, in this video we'll be talking about allosteric regulation of an enzyme activity. Okay, so the enzyme which is regulated by some mechanism, okay, such as allosteric mechanism, that enzyme is known as allosteric enzyme and that regulation is known as allosteric regulation. So allosteric enzyme is a regulatory enzyme. So what do you mean by a regulatory enzyme? So if you take any metabolic pathway in our body like carbohydrate metabolism, lipid metabolism, protein metabolism. Suppose example carbohydrate metabolism, glycolysis or 𝗕𝐧𝐼 cycle. Okay, so there are set of reactions like glucose is converted to glucose 6-phosphate, glucose 6-phosphate to fructose 6-phosphate. So like this, there are total 9 reactions and the end product will be pyruvate. Right. For this, one enzyme has to be regulated because not all the time we require glycolysis to produce pyruvate and pyruvate to acetyl-CoA, 𝗕𝐧𝐼 cycle energy. At times, we are with sufficient amounts of energy and no need to produce the energy again. So that means that pathway has to be regulated based on the situation like switch on, switch off. Right. So this allosteric regulation will provide particular metabolic pathway to be switch on, switch off, okay, based on the need of the cell. Right. And that type of regulation is known as allosteric regulation. And the term allosteric derives from the Greek word that means allo means other or stereo means space. So why this is known as allosteric regulation? Here the modulators, that means we have studied about active site of the enzyme. Okay, the site where substrate will go and bind and forms enzyme substrate complex and reaction proceeds further to form product. But here allosteric regulation, enzymes do carry some other place rather than active site, that is known as allosteric site. Okay, so allosteric site is nothing but the place is other than active site over the enzyme. So allosteric enzymes which are having other site in addition to active site like binding of modulator, because there are allosteric modulators which are involved in allosteric regulation. Okay, so they might be positive modulator, negative modulator. So if positive modulator goes and binds to the allosteric enzyme, okay, it initiates the reaction, okay, with a certain speed. Okay, there is a formation of product. But the same allosteric site, if negative modulator binds, reaction will not be taking place further, okay, and there is a stoppage of the reaction there itself. Okay, so allosteric site will be the same. It depends which modulator goes and bind to the negative or positive modulator goes and binds to the allosteric site. Okay, so allosteric enzymes may be inhibited or stimulated by the modulators. So that's the work of negative and positive modulators. So modulators which is inhibiting enzyme activity known as negative modulators, and modulators which increasing the enzyme activity known as positive modulators. So you see here in the picture, you can make out nicely. So allosteric enzyme, example, the mechanism. So allosteric site, that means you see here this blue color, okay, the place. So this is active site, that means catalytic site, okay, catalytic site or active site, and this this is known as allosteric site. Okay, so two are there in allosteric regulation, positive regulator and negative regulator modulator. Okay, so if here positive modulator is in red color, okay, so if this goes and binds to this allosteric site, okay, it will allow the substrate binding, okay, it will allow the substrate binding to the active site and form enzyme substrate complex, and there is formation of product. That means positive modulator is facilitating or pushing catalytic site of the enzyme to bind to the substrate and forms the enzyme substrate complex, and there is a formation of product. Okay, but same to the allosteric site, here negative modulator, okay, in blue color, okay, which is goes and binds to the allosteric site. Okay, it will not allow substrate to bind to the catalytic site or active site of the enzyme. There is no enzyme substrate complex and there is no product formation. So this way allosteric regulation will work by making use of negative modulator and positive modulators. So you take one best example of heme synthesis. Okay, heme synthesis, here the spelling mistake, it is heme. Okay, glycine and succinyl-CoA are the starting substrate for synthesis of heme. Okay, and the first formed product, that is delta aminolevulinic acid, Okay, and this is enzyme 1, that is ALA, amino levulinic acid synthase, ALA synthase. So finally the last product is, end product is heme. So when heme is synthesized, this heme will go and inhibit the first enzyme, that is ALA. So heme is a negative modulator for ALA. Okay, it goes and binds to the allosteric site of the enzyme, that is ALA synthase, and it will not allow to form amino levulinic acid further. Okay, so this way heme synthesis is regulated by allosteric regulation, because here the end product only will inhibiting the first enzyme, right? So that's all about allosteric regulation of the enzyme. Thanks for listening. Thank you.